Hello, welcome to the Bimmy Boy Magic Show, presented to you by Kainoa and Tyler. Today, I'm going to be doing a science experiment, layering liquids and diving down to see how intermolecular forces affect each liquid differently. For our first liquid, we're going to be using honey. For our second liquid, we're going to be using dish soap. Our third liquid is going to be tap water. And our final liquid is going to be canola oil. From what we've previously learned, this effect is caused by different densities. You may be wondering what this has to do with intermolecular forces. First, let's take a closer look at each substance individually. As you can see here, we have water on the left and oil on the right. If we take a closer look at their meniscus, you can see that the water has a larger and deeper meniscus compared to the oil. This is because water has stronger intermolecular forces. These stronger forces allow for more flexibility in the liquid before it gives like the oil. This experiment of why these substances don't mix has a concept buried inside of it. Let's take a closer look at just oil and water. Even if two substances have different densities, they can still mix. What's so special about these? Water and oil have different polarities. Water is polar and oil is nonpolar. The rule for polarities is that like dissolves like. So another polar substance would dissolve in water and another nonpolar substance would dissolve in oil.
For the second segment of our magic show, we have the mason jar and the screen trick. For our first liquid, I chose water. I filled the cup about halfway. Then, I put the lid on top and flipped it over. As you can see, the lid stayed on the bottom of the cup. This is because there's atmospheric pressure, which is the force that holds the cap in place. It stays upside down on the jar because the pressure of the air molecules pushing up on the cap is greater than the weight of the water pushing down. When I pulled the cap away, the water stayed in the jar. The answer for that is surface tension. The surface of the liquid has a thin membrane stretched over it, a force called cohesion, which is the attraction of similar molecules to each other. The water stays in the jar even though the card is removed because the molecules of water are joined together through cohesion to form a thin membrane between each tiny opening in the screen. The next liquid I used was Japanese cooking wine, or sake. I again poured the cup about halfway full. After there's a sufficient amount of sake in the cup, I'll do the same trick again, but with this different liquid. I then put the lid on top of the jar, flipped it over, and it stayed there. This is atmospheric pressure again. Once I removed the lid, all the liquid came out. That's because the surface tension isn't as strong as water.